So let's talk about, let's end phase 1 with lecture or section, not 7. And that is on, let's say, probability distributions and random variables. Let's give that to A. So, if we want to examine an experiment a little bit more as a whole to see how likely are all the different things that could happen, then let's say a little bit first so you can have notes that make sense. So let's say we might want to examine the probabilities of all the outcomes in the experiment. Of all outcomes in the experiment that I'm looking at. So to that end, we define a variable to represent all the each outcome. Just to make it a little bit more easier to write, to be able to write the probabilities for all the outcomes sort of in a more convenient way, we define a variable to represent the different or various outcomes. Now that's all a little vague. Let's look at something specific. For example, I could say let's roll 2 dice. That's my experiment. And what is considered to be an outcome? Let's say we observe the sum of the values. So that's my experiment. I roll 2 dice and I look at the numbers that I get, I add them up, and that is the result of my experiment. Not the pair of numbers, let's say just adding them up, just the sum. So then I can define X to represent the possible values that I can get. So X can have values, or let's say possible values. Oh, we already wrote possible there. Values, what are the values that X can have? So X doesn't have one specific value because I have different possible outcomes to my experiment. I just give X, I just call X the thing that represents those possibilities. What are the possible values that I can get? If I do this experiment, I write the result on my page. What are the different things that I could write on my page? What is the smallest number I could write on my page? 2, the smallest. If I have 2 ones, the sum will be a 2. Can I get a 3?
Yeah.
4? How far do I go?
To 12.
Estimating to write up to these dots. So 2 all the way to 12. 2 ones will give me this, and then a combination can give me anything in between, all the way to 2 sixes. But an outcome, according to the description of my experiment, is just the sum of the 2 values. So these are the possible values that X can have. And there is a probability associated with each of these values. With each value of x. So those are my possible outcomes, not too many in this case, and each one has a probability of occurring. Maybe this one's more likely than this one. So I have associated probabilities with each of these guys. So a variable like this is called a random variable. That's not really the correct word, but most books these days call it a random variable. Because sort of the word random sort of hints at the fact that I don't have one value for the variable, I have multiple possible values, and each one has a different likelihood of occurring. So now let's look at how I'm going to turn this. Let's look at our example. And I'll say some things as we go through this. This example sort of leads me through the different things I want to talk about. So now I have a slightly different experiment. In example 1, suppose a die is rolled twice. Let x denote the maximum value to appear in the rolls. Slightly different, though I'm all doing very similar action, what I observe is different. So they define x for me, so let me just sort of remind myself the maximum value. So the first thing, if they ask it or not, I have to list all the possible values of x, or at least have a clear idea about what values x can have. So let's say your x can, or just say has values. What are the different values that x can have? If x denotes the maximum value to appear on in the two rows. What is maximum value? What does maximum mean? 12. Maximum means 12?
The highest.
What is the highest? Yes. So what are the possible highest values that I could get? So I'm doing the experiment. I have two rows. I write down the maximum, and that's my outcome of the experiment. What are the possible things that I can write on my page? Pretend you're doing this. What is the smallest number I can write on my page? 2 is the smallest? How would you get a maximum value of 2? Well, how would you get a 2? He says, if you roll these two numbers, you get a maximum of 2. What does maximum mean? Maximum means the highest possible outcome among these dice rolls. What is the highest number? 1. So the corresponding value of x is 1. The biggest of the two. Maximum. It's Monday, it's not even Friday. Not the sum. Different variable. Different experiment. Even though I'm always going to call it x, something like that. Usually a capital X or a Y or something like that is the name for a variable, for a random variable. But every time it means something else. Can I get a 2? How would I get a 2? For example. 2 and 1, 2 and 2. I can have many combinations. Well, not many, some combinations. Can I get a 3? X is the name for the possible things that I could write on my page.
You get a 2 if it's 1, 2.
So 1, 2 means, let's say that the 2 This is different than this one because I have a first row and a second row. But when I look at these numbers, X represents the biggest of the numbers that I got. That's the outcome, that's the result of my experiment. So regardless, any of these pairs will result in X having the value 2. Can I get a 3? Now, where do I go? How would I get a 6?
6, 1, 2, 6, 3, 6, 4.
Many. Anything with a 6 in it. The highest number is 6. Is everyone happy what I mean by maximum value?
So it said maximum sum, that means,
That'll be different. So I can define a lot of different meanings for X. In this specific case, X denotes the maximum value in the pair of numbers that I get. And that is what an outcome of my experiment. So 2 things are important: the actual experiment that I'm doing and the meaning of X. Those all affect the possible values. And it's important to be aware of both of those things. What is my experiment and what does the variable represent in this case? It's not always going to be the same. So I have to just read carefully and then think, what are the possible values? Okay, let's look at B. Now that tells me what are the probabilities that are associated with these 6 possible values that X can have. Well, in the setting of this lecture, random variables, we're not going to get fancy with our probability calculations, so it'll be much more straightforward. Let's make a table to see for, let's say, the different outcomes, just to see what is possible and how can I figure out the probability. So let's say here I have my first row and my second row. So I could have a 1, a 2, a 3, 4, 5, or 6 on the first row. My experiment, they say roll the die twice. So the second row could be 1, 2, 3, 4, 5, and 6. Oh, that's not 6. And try and separate these guys. So I want to see all the different combinations and how they can give me one of those X values. So let me shade this. This is the specific dice rolls, giving me a sequence of 2, a first and a second one. If I roll a 1 and a 1, what is the maximum value? 1. A 2 and a 1 will give me a maximum value of 2. A 3 and a 1. You're gonna have to help me here.
3.
I don't want to waste too much time with
4,
this.
5, 6.
Anything with a 1 is just going to be the other guy. Let's pull this column in. If I roll a 1 with any of these, this one's going to be the maximum. So these are the X values that I'm writing down here, the maximum of the 2 values. A 2 and a 2 is going to give me a 2. You can pull this out any way you want. A 2 with a 3, and this top guy takes over, and he's going to be the maximum value. If I go down the column here, a 2 with a 3, 4, 5, 6, well, that second roll is going to be the highest one. Is everyone making sense of this, what I'm doing here? I have 2 rolls in my experiment. What is the corresponding maximum value, the corresponding value of X? 2 3s will give me a 3, then a 3 and a 4, 3 and a 5, 3 and a 6. Same with this, 3, and any of these larger numbers will give me that number. 2 4s, maximum number is 4. 4 with 5 and 6, so I can quickly fold these in now. Any questions on the table? Just to see all the possible combinations of what I can get. That's all I'm trying to do here. These are the x values. These are the x values. Now I have to always remember what x represents. X represents the maximum number among the two dice rolls. So now, how do I calculate the probability? So we're going to write P for probability, and then square brackets x equals, let's say, some number n. This represents the probability that x has the value n. And n can be 1, 2, 3, all the way to 6. You can plug in any value of n if you want. So now I go down the list, and we write them over here, and I can say the probability that x equals 1 is my lowest number, so let's start with 1 and work our way to 6. How do I find the probability? I count the number of ways that can happen divided by all possible ways. How many possible outcomes are there in this table? 36. 6 by 6 table. 36 different pairs will give me a value of x. How many of these guys give me a value of 1? Only 1. So the probability is 1 out of 36 possibilities will give me x equals 1. So the probability calculation isn't complicated. What is the probability that x equals 2? Well, I have 36 possible pairs that result in a value of x. How many of them have a value of 2? 3 of them. Now I just go down the line. We don't have that many possibilities. How many of the values 3? Seems like it's 5. Not that many to do. So take note of the notation. Slightly different because I'm referring to my variable that has a specific value. This represents an event if you want. The probability that x equals 4 over 36, how many 4s do I have? I have 4 of them and then plus another 3. 7. 2 more, x equals 5. I have that whole row of 5 and then another 4. So that gives me 9. 1 more. 11 out of 36. Now it's all good and well to list them like this, but what if I have a bunch more? Then the listing method is going to get a little bit clumsy. Can I find a pattern in these numbers? Well, if I look at the table, that might help me. Look at 3, for example. If I'm in row 3, I'm counting the number of 3s. I have 3 of them, all the way up to the corresponding column, and then 2 more. So I can write this guy as 2 times 3, which gives me 6. It's 1 more than I need.
You mean for this one?
So that's totally what I meant. I just saw a 3 and I went for it. This one. 2 times 3 minus 1. Let's see what happens with this one. I'm trying to see a pattern so that I don't have to list them all. I can sort of merge them into one expression. When I'm looking for the outcome of 4, I have 4 of them in the row, and then 1 less up. So it's almost 4 and 4. So it's almost 2 groups of 4, but I have one less than that. Giving me 7. Does that work for the 5 group? I have 5 in a row there, 5 5s, and then almost 5 up, so almost 2 groups of 5. There's 1 too many. and this one will be 2 groups of 6, 1 too many, so I have to subtract 1. So I have two methods or two ways to present my probabilities. The one that we'll do mainly is, let's say, present all the probabilities. Let's do the bad one first. Probabilities. I can do it as a function. So let's say here 1 as a function, meaning a formula that will merge all of these guys. My function is, I'll call it little p of, I'll call it n, I don't really care. Different values that I can put in here. What is my function? It looks like it's 2 times n minus 1 over 36. What are the possible values of n? 1, 2, all the way to 6. So this means I can plug in the value of 1. Do I get the right probability? The first one. 2 times 1 is 2, minus 1 is 1, and I'm looking for a 1. So I'm trying to merge all that into a single formula. But I have to skip back. Does it work for 2? 2 times 2 is 4, minus 1 is the 3 that I'm looking for. All the way to n equal to 6 will give me the 11 that I'm looking for. Now, you can relax. I'm not expecting you to make these formulas. I just want you to be aware that that's one way to get away from the list. The other way is to make a table, a little bit more concise than that. Let's say it has a table, and then I can just say, well, let's list the, let's say here, n value. 1, 2, 3, 4, 5, 6. And then let's list the corresponding probability that x equals that value. Just make a table. Write them all out. 1 over 36, 3 over 36, 5 over 36, 7 over 36, and 9 over 36, and 11 over 36. So, yes, the table method is still going to be a little tedious if I have a lot of different possible values that x can have. But for our purposes, this is sufficient. But it's good to be aware that if this becomes too big, then a single function or a single formula is going to be really the only way to go. So as soon as things become fancier, if you continue with statistics course, then this is the direction that we'll go in. But for our purposes, making a little table is more than sufficient. So let's give these guys a name. So we call, I guess, this, any one of these, whether it's a table format or a single function, we call this the probability distribution of my random variable, which is x in this case. This tells me how the probability is distributed over the different possible values. So probability distribution. Any questions on how to represent these things and so on? So again, I'm not expecting you for this course to be able to write down the single function, the formula. The table format is more than sufficient for what we want to do. But listing all the probabilities gives me a lot of information about the experiment. It tells me, this guy is not very likely. As I go through the numbers, the bigger numbers are more likely to occur as a maximum of the band. So it tells me how the probability is spread over the possible values. Let's note here, what do these probabilities add up to? They're fractions. What do these fractions add up to? 1. Does that make sense that they add up to 1? Why does that make sense?
36 over 36.
Yeah, but if I didn't give you these numbers, I just smudged them out. And I changed the experiment a little bit. If I run over all the possibilities, will the probabilities always add up to 1? Yeah, because something's going to happen. One of these guys will happen. So each one has a little piece of the 100% probability that something's going to happen. Each is a little piece of my sample space. If I add them all up, I'm always going to get the sum of 1. Because it's a probability distribution, it has that property that these guys will always total 1. So if I give you all but one of them, and I ask you, what is this probability? I can easily find it by just taking the rest away from 1. And that guy is sort of forced to be the other little piece. Does that make sense? Why they should add up to 1? Okay. So we did part C right there. This is the probability distribution. Let's call that C. Another word for it, this is sort of old, these notes are old, and the example sheet I didn't update. When you talk about this guy, a function, we call that a probability mass function. But from now on, I'll just use probability distribution, because I'm not expecting you to write the function. We'll stick to the table format. Okay, so let's see now if we have all the probabilities listed. Let's say like this. Okay, they're a little messy. You have them on your page, so I'll fold it back in. I can answer something like D. What is the probability that the maximum value is at most 2? Now, how do I write this down? I'm going to say the probability that X is at most 2. That means at most, because it's everything up to 2, less than or equal to 2. So what do I do when I see an at most or an at least? I split it up into specific pieces. So that means X could be 0, or X could be 1, or X could be 2. Split it up. Now I know exactly what I'm looking for, and I can add up the probabilities separately. Just 0, just 1, and just 2. I look at my table. This one I can no, does this make any sense? No one stopped me. I'm just trying to see if you're awake or not. X equal to 0 doesn't make any sense. There's no X equal to 0, then it starts with 1. So we don't need any of this. We don't need that. There's even fewer possibilities. Just 1 or 2. And I can just add them up separately. So it's important to be aware, what are my range of values? If I have an at most or an at least, it's everything up to 2. Where do I start? Only 1. 1 and 2. So 1 had probability 1 over 36. 2 had probability 3 over 36. So my probability is 4 over 36. You can simplify that if you want. I really don't care. What's important is I can, from the table, from the distribution, I can answer all the questions about the probability of some combination of these things. What is the probability that I get an even value, 2, 4, and 6, and I just add those up. I can add up whatever they're looking for. Any questions on B? All right.